Hello, today we'll be talking about basic matrices. And mainly in algebra, we use matrices to help us solve systems of equations. The first thing we have to know is how to convert a system of equations to a matrix. Alright, so example 1. All we do is make brackets, and we're just copying the coefficients in front of each variable into the matrix. Now there's an x column, a y column, and then a constant column. And this bar just represents our equal sign. So the coefficients in front of all of our letters, remember no letters go in here. Alright, so we just have the number in front of x is 3, number in front of y is -2, and equals 6. Here, same thing, just copying the coefficients. So the number in front of x, there's nothing there, so that means it's a 1. Same case for the y here, and the 3 last. And using different methods, we can solve this without all the x's and y's. One way is the Gaussian elimination, but that'll be in a different video. Alright, so just doing that for all 4 of these, really quick. First row we have no x, so that means it's a 0 for the x column. The y is -1, bar means equals, and -1 after the equal sign. Next one would be 1/2, -2, and 0. So we're just copying the coefficients just right into the matrix. It actually doesn't matter which equation you use first. You can put this one on top, or you can put this one on top. Does not matter. Alright, so these are even more useful for solving equations with x, y, and z. But once again, we still just have to know how to write the matrix. And it's the same case. And it doesn't matter which one you use first. So you can flip them around if you want to. This would be 1, -4, 2, after the bar, 3, 1, -4, 2, 3, -1, -2, 3, -2. And 4, 1, -1, 1. And one more. Remember, if the letters don't show up in the equations, that means it's 0, because it would be 0 times y, 0 times anything is 0, so it would go away. So for our first one, we have 1, 1, 1, and 3. -2, there's no y, so that means 0. -2, 0, -2, -4. And the last one, 2, -1, 0, and 1. Alright, next we're going to be talking about the determinants of a 2x2 matrix. Once again, this is just another way that helps us solve them using different methods. Alright, so the determinant of a 2x2 matrix is just the first diagonal, so multiply those, minus the second diagonal, and you multiply those. So for this case, we'd have 1 times 4 minus 3 times 1. And then you use order of operations from there. Equals 4 minus 3. And the determinant of this guy would be 1. Now, what denotes a determinant is the absolute value bars around it. Now, you could either have your matrix in brackets with those around it, that means take the determinant, or you could just have the absolute value right around the matrix without the brackets. You don't need them to denote a determinant. So for this one, we'd have our first diagonal, 3 times -1, minus the second diagonal, 1 times 8. which would be -3 minus 8 which is negative 11. Now, if everything inside your matrix is the same, we would have here 1 times 1 minus 1 times 1, just this diagonal minus this diagonal, which gives us 1 minus 1, which is 0. So if everything in the matrix is the same, you get 0. And one more example, negative 2 times 5 minus 4 times 8, which is negative 10 minus 32 is negative 42. So generally, the determinant of a 2 by 2 matrix is going to look something like this. Say we had just letters. A, B, C, D. So our determinant is going to be A times D minus B times C. Alright, and last I'll be talking about determinants of a 3 by 3 matrix. And actually these aren't so bad. There are 3 different ways of doing it. I'm just going to show you one. I think it's the best way of doing these. What you do is copy the same matrix under itself, but really you only need the first 2 lines. So 1, 0, 2, negative 1, 2, 0. And what you do is kind of similar to the 2 by 2 matrix. Alright? So here we have our first diagonal, 1 times 2 times negative 1. Put that in parentheses. 1 times 2 times negative 1 is negative 2. Then our second diagonal, negative 1 times 2. Negative 1 times 2 is negative 2 again. And then our third diagonal, 3 times 0 times 0. Well, that's just 0. And then we subtract the diagonal coming from this direction. So I'll do that in a different color. So diagonal coming from this direction, 2 times 3 is 12. 0 times anything is going to be 0. And then we have negative 1 times 0 times negative 1. And once again, 0 times anything is 0. And now we can start simplifying. So the determinant of the original matrix, even though it looks messy now, is negative 4 minus 12. And negative 4 minus 12 is just negative 16. Alright, and the last one, we'll go ahead and copy the matrix under itself. 0, 0, 4, and 2, 1, 8. But remember what I said, you really only need the first 2 lines. So, go ahead and do it. First diagonal, 1, 0, 8, just multiplying these 3. And we get 0, 0, 1, 2, so plus 0, and multiplying 2 times 4, which is 32, minus the diagonals coming from the right-hand side. So we have 2 times 0 times 2, that's 0, plus 4 times 1, that's 4. And then we have 8 times 4 times 0, which is 0 again. So our determinant here is just going to be 32 minus 4, which is 28. one last thing. Whenever we say a 3 by 3 matrix, the first number represents the number of rows. And the second number represents the number of columns. All right, so for example, if I said we had a 2 by 4 matrix, it might look something like this. 2 rows and 4 columns. And our matrix would look like that. But we can actually only take the determinant of a matrix that's a square. So a 3 by 3, a 2 by 2. So we actually can't take the determinant of anything like this. And that's all I have for today. Thank you.